So in today's lesson, we're going to learn about the cosine law. And so hopefully you found the sine law okay. The reality is that the sine law can't be used in all problems. So for example, I'm just going to draw out a triangle here, really rough, right? And let's say this is the information that I had. Let's say I had that one of the angles was, I'm just arbitrarily choosing 40 degrees. And let's say I had two of the sides, but these were the sides that I had. Let's say I had one that was 12 meters, and I had this side over here that was 15 meters. And so, I would encourage you to pause the video and see if you can solve this using the sine law. Well, the sine law requires you to have an angle and an opposite side to be able to relate. And in this case, I'm missing the other part of the equation. If I don't have another angle, then I can't use the sine law. Or if I don't have the side opposite the known angle, then I can't use the sine law. So for that reason, I'm going to introduce you to a different tool, which is the law of cosines. So let's take a look at that. So the cosine law reads as follows. So it's a little bit more involved than the law of sines, and so we're going to need to pay attention to some details. So first of all, you'll remember earlier on when we were talking about similar triangles, I discussed how typically the convention is in math, if a vertex is labeled as using a capital letter, then the side opposite that vertex is typically assigned the lowercase version of that letter. So for instance, this would be lowercase a. The side opposite vertex B would be side little b, and so on and so forth. I'm just going to go like that, little c. All right, and so if we're relating the sides and angles using the cosine law, we would say for an acute triangle, and again, you'll learn about how to deal with obtuse triangles in grade 11, then the cosine law reads as follows. We would say we would find out the length of A, that's A right here, A squared is equal to B squared plus C squared minus 2BC cos times the cos of angle A. Now this seems like a lot, but let's just break it down. I'm hoping you're feeling like the first part of this looks a lot like the Pythagorean theorem. And it does. But we need to adjust for the fact that this is not a right-angled triangle here. And so there's a bit of, this little bit represents a bit of a fudge factor to just account for the fact that it's not a right-angled triangle. But let's look at the structure of this. So a few things that are worth noting is that if I'm trying to find side A, which is all by itself on one side, then I'm taking the cos of the angle opposite that side. Okay, so those have to relate to each other. I'm going to highlight them. So there's that, and then there's that. And then it's always going to be equal to the square of the other sides added together minus 2BC. So notice that relationship there, right? So if I have B squared and C squared here, then I'm subtracting 2BC. Okay, now keep in mind though that these are all multiplied together. So what I want you to do is to take a minute, because of course the sides won't always be labeled as A, B, C, and neither will the vertices. So how might I write this if the triangle were instead, if the information I were trying to find were for side B instead? How would I set up that? So take a minute to give that a whirl, pause the video, and try to write it out. And when you're ready, resume the video. Okay, so if I were writing out the cosine law in terms of side little b, I would write b squared is equal to the square of the other two sides, which are a and c, so a squared plus c squared, minus 2 times AC times the cos of angle B. So again, just remembering that these need to correspond. If you didn't get that, Well, I want you to pause the video and try this again for side C. So for side C, I would write out the law of cosines as c squared is equal to a squared, oops, let me just use a different color there, a squared plus b squared minus 2ab times the cosine of C, of angle C. So again, just maintaining that little bit and then noticing the relationship here. Okay, let's try a question. So our first example reads, and just to keep things simple, I've chosen to use, A, B, C as my labels, just to get our feet wet a little bit. So in triangle ABC, angle B is 42 degrees, little a is 52 meters, and little c is 36 meters. Find little b, so that's the side length to the nearest meter. So I would strongly encourage you to draw a diagram just to, get a sense of what it is that you're looking at. Remember that, this section is dealing with the cosine law, but often you can't really tell easily unless you draw a diagram which of those two tools is appropriate for a given question. So I just find it's good practice just to get my head around the question itself. So I'm going to go ahead and draw a triangle. I want you to pause the video and do the same thing, and we'll compare what we get. Alright, so there's my labeled triangle. I find it helpful to label all of the vertices and the sides just to keep in mind what all of my knowns are. So now I'm asked to find out B, and so if I'm going to find out B, then I'm going to write my law of cosines out with respect to side B. So let me just do that. So I know that side B squared is going to be equal to side A squared plus side C squared minus 2AC times the cosine of angle B. So a few things I need to make sure I have before I can utilize the law of cosines is I need to make sure I have angle B and that I have side A and side C. And it looks like I do. And so this is a perfect situation for me to use the law of cosines. So now I'm just going to go ahead and substitute the information in to the question that I know. So B squared is equal to 52 squared plus 36 squared minus 2 times 52 times 36. I'm running out of room. I'm just going to make this a little bit smaller. Times the cosine of 42 degrees. All right, so now a couple of things I want to mention to you in terms of errors that I see. We need to remember bed mass. Remember that from like grade, I don't even know. Bed mass. So remember, we always want to, multiply before we add and subtract. And so what that means for us is that before we subtract all of this, we need to multiply all of this together. I often will see students trying to multiply 2 times 52 times 36 and then subtract that from whatever this is before multiplying it by cos of 42. So I'm going to break this down for you so that you can avoid making that error, and unless you're really comfortable with it, I would suggest you might want to do that. So now B squared is equal to, and now what I'm going to do is I'm just going to calculate 52 squared using my calculator. And that's giving me 2704. And now I'm going to do the same thing for 36. So 36 squared is 1296. And now I'm going to say minus, now I'm going to deal with this whole bit right here, minus all of this. So what I'm going to do first is I'm going to multiply 2, 52, and 36. So minus 3744 cos of 42 degrees. So don't forget what I said about bed mass. We want to make sure we deal with this first, this multiplication, before we go ahead and do the subtraction, right? I can't say this minus that because I haven't multiplied it by cos 42 yet. So I'm going to continue to break this down. And you know what? Once you get comfortable with what you need to do, you won't need to break it down like this, but I'm going to go ahead and do that. So I'm just going to add these two values together. So 2704 plus 1296. I'm getting 4,000. And now what I'm going to do is multiply this 3744 cos of 42 to get a value. And I'm getting 2782 approximately. So now I'm just going to clean this up. Oops. And that's going to give me 1218. And now, of course, just to isolate b and to undo my square, I need to take the square root of each side. And so when I do that, I get that b is equal to approximately, and I'm going to round, it doesn't tell me, oh, it does say, it says round to the nearest meter. So I'm getting 34.8998, blah, blah, blah. So I'm going to round that to 35 to the nearest meter. And I'm not going to forget that unit because the unit is important here. Now, remember from the last unit that whenever we end up with a square root, we have to look at the positive and the negative possibility here. But I'm not going to include the negative root of this because it doesn't make sense in the context of b representing a length. So there we go. That is how you find a side length using the law of cosines. Next, what we're going to do instead is we're going to solve for an unknown angle, and you're going to see that that's a little bit more involved, but I think you'll manage it just fine. All right, so let's take a look at this next example. It says in triangle DEF, little d is 62 centimeters, little e is 51 centimeters, and little f is 48 centimeters. Find each angle of the triangle to the nearest degree. Okay, so in this case, what I want you to do is I want you to pause the video and do a few things. First of all, I want you to draw the diagram. Okay, so I want you to do the diagram. And I want you to set up the law of cosines, okay? And then I also want you to sub in some values, okay? So sub your values in. So those three things I want you to do before you start the video again, and then we will catch up. Okay, so in this case, they're asking us to find the angle, but it's not telling us which example or which angle to find. So you can sort of choose. So I'm going to go ahead and I'm going to choose to find out angle D. So if I'm finding out angle D, then I need to set up my law of cosines with respect to side little d, and that's how I'm going to choose to write that out. So I'm going to go, oops, let me use a different color here. D squared is equal to e squared plus f squared minus 2ef times the cosine of angle D. And again, see that relationship there, right? So if I'm solving for angle D, then that's how I would want to set it up. And I could have just as easily chosen angle E or angle F and set it up otherwise. But I've just arbitrarily chosen to solve for angle D. So now let's substitute some values in here. So I actually know the value of side D, which is 62 centimeters. And I also know the other two sides. So side E is 51 centimeters, so 62 squared, 51 squared. And side little f was 48, so 48 squared minus 2 times 51 times 48 times the cosine of angle D. Okay, so it's in the cleanup here that things can get a little bit challenging. So I'm going to do a few things and then come back. So first of all, I'm going to evaluate these. I'm going to get these exponents out of the way, and I'm also going to clean up this little part right here. So all I've done here is I've simply just squared these values, and then I've multiplied that out and I've received these values. Okay, now again, we don't want to fall into the same trap as I talked about last time, which is, to subtract this. I see a lot of students wanting to do that. But remember, this negative 4896 is attached to cos D. That is a multiplication. So I can't subtract before I multiply. So I'm going to clean this up a little bit further. So what I need to do next is I need to take these values here and I need to move them to the other side and subtract them from the 3844, right? And what that will achieve for me is that I will have isolated this negative 4896 cos D, and that's going to lead me to help to eventually isolate cos D. That is my plan. So I'm going to go ahead and do that. So when I do that, I am getting negative 1061 equals negative 4896 cos of angle D. All right, and so now what should I do next? Well, how am I going to undo this multiplication with cos D? Well, I'm going to isolate by dividing out the negative 4896 on both sides. And so when I do that, I get .2167 approximately, and that's equal to cos D. Right? So now, but I haven't solved for D yet. I have only solved for cos D. And so at this point, I have to use my technique for solving for angles, which is to use the cos to the negative 1 function. So that is what I'm going to do. So I know that angle D is equal to cos to the negative 1. I'm going to use that that inverse operation of 0.2167. And when I do that, .77 degrees. So there we have it. And I like to kind of fill in as I go into my diagram, just so I'm keeping track of what I know. So I know now that this angle right here is 77 degrees. So now, could I use the law of cosines to help solve for the other angles? Sure, but as hopefully you're seeing, the law of cosines is a lot more involved than the law of sines. So personally, I try to utilize the law of sines whenever possible. Now I'm in a situation where I can actually use the law of sines because I have that situation where I have the angle and the opposite side. So that is what I'm going to do. So that's what I'm going to do. I'm going to call this step number 2. I've already found angle D, so now I'm going to choose to find angle E. So I know that the sine of angle E over side little e is going to be equal to, and what are the other two pieces of information I have? I have angle D and I have side little d. So I'm going to relate my sine law using sides and angles E and sides and angles D. So sine of angle D over little d. And this is a lot simpler, I'm hoping you're seeing. So sine of E over little e, which was 51 centimeters, is equal to sine of angle D, which we just solved at 77 degrees, over little d, which is 62 centimeters. Now I'm just going to isolate sine E by bringing the 51 upstairs. So sine of E is going to be equal to sine 77 degrees over 62 times 51. All right, so let's just clean things up here. When I perform this multiplication, I end up getting 0.8015 rounded. And now I need to solve for angle E. So I'm going to use the inverse operation to solve for my unknown angle, which is to say, well, sine to the negative 1 of that value. Oops, 8015. So angle E ends up being 53 degrees. If you're not finding that you're getting the right answers, just double check that your calculator is in degree mode and not in radian or gradient mode. That often is the trick. Okay, so now I can go back to my diagram over here and I can say, all right, well, I know now that angle E is 53 degrees. So the easiest way now to find my third angle is to go ahead and use triangle sum, because that is easy peasy, right? I know that all the angles in my triangle have to add up to 180 degrees, so I know that angle F is going to be 180 degrees minus 53 degrees and minus that first angle we found, which was angle D as 77 degrees. And working that out, I get that angle F is 50 degrees. So there I have it. I have all three angles. I didn't need to use the law of cosines for all of the information, though I could have. I think by using alternate methods, I saved myself quite a bit of time, but there are times where you really can't avoid using the law of cosines, and so that's how you would go about it. This can be tricky. I'm going to strongly encourage you to work through the practice problems that I set out for you to master this skill. But there's a couple little pointers I want to mention to you, because you will, eventually encounter situations where you have to decide between the law of sines and the law of cosines. And so here is some advice. So when you arrive at a question and you have to decide whether the sine law is appropriate or the cosine law is appropriate, here are a few pointers. So I would say you want to use the sine law when you have a side and its opposite angle, and you want to know, an unknown side or another angle. So, the only way the law of cosine is really the law of sine is going to work is if you have, let's say, for example, I have triangle ABC, then I have little a, little c, little b. I have to have an angle and its opposite side. That is information I need to have for sure. And if I have that, then I'm good to go. If I don't have an angle and its opposite side, then I can't really use the law of sines, and in which case I would have to go to the law of cosines. Now, as we saw before, the law of sines, which just is a ratio of sides and angles, is a lot more straightforward than the law of cosines. Having said that, with the law of cosines, there are a couple of cases where you kind of have to use the law of cosines. And one is when you don't know any of the angles and you have all three side lengths. That is, like, to me, the time where you have to use the law of cosine. So for example, if I'm given A, B, and C here, and I don't have any of the angles, and what I'm looking for is the angles. Another case is that if you have two sides and the contained angle. What do I mean by the contained angle? Well, I mean that the angle itself, let's say, for example, is right here, and I know the other two sides. So let's say this is side A and this is side B. So in this case, I can't use the law of sines because if I wanted to use the law of sines, I'd need to have the opposite side, but I don't have it, right? So again, law of cosines, quick way to identify is if you don't have any of the angles, or if you have the angle and the contained angle, the angle is contained by the two sides. All right, so good luck with the practice today. As always, reach out. I'm going to assign you some work so that you can, but be sure to check your answers. It's easy to go wrong with the law of cosines, particularly when you're solving for an angle. So take your time with it, and as always, reach out.